So hello everyone, welcome to Learn Overflow. In this video, we'll again discuss on one of the competitive coding programmings, and this question is there on CodeChef again. So this question goes with the title Tweedle-Dee and Tweedle-Dum. So you can see the programming code is Tweed. All right, let's go through the question and understand what the question tries to ask us to solve. So it says there are Tweedledee and Tweedledum are in a fierce battle, and they're playing an even odd name. All right, so it's a game of name. So it says this novel game is played on n heaps, and the heap at I position contains a of I stones. All right, so that's the number of stones it have. Like I position have I number of stones. All right, now like normal name, Tweedledee and Tweedledum alternate taking the positive number of stones. Take a positive number of stones from any single one heap, and the player that can't remove stones loses. Okay, so what's the usual game is? So there will be different heaps in different heaps, and there will be each heap have different number of AI number of stones in it. So if Tweedledee and Tweedledum would go and pick number of stones from it, and they need to take a positive number of stones. So taking zero number of stones isn't a valid case. All right. So that's what they mean by this statement: a positive number of stones from any single one of the heap. Okay, so they can pick up from any one of the heap any positive number of stones. Okay, that's what it's saying till now. And the player that can't remove a stone. Okay, so in case a player goes and can't take up any stone, that means takes up zero stones, loses the game. All right, so you need to pick up a stone to win the game. All right, so this is what it's said till now. However, Tweedle-Dee. Okay, let's do something. Let's throw out this video, call Tweedle-Dee as only D and call Tweedle-Dum as only Dum. So I guess that would be easier to name them. Okay, however, Tweedle-Dee can only take an even number of stones, and Tweedle-Dum can only take odd number of stones. So there comes the twist. Look, D can take even number of stones, and Dum can take odd number of stones. So there's the twist here, that whenever they are going to pick up a stone, they are trying to pick up a stone. In case they don't find an even number of stones, remember valid is not a remember zero is not a valid case. So for the minimum number of stone that D can pick up is 2, right? And the minimum number of stone that Dum can pick up is 1. All right, so this goes that D can only take even number of stones and Dum can only take odd number of stones. Let's understand further what else they ask in this question. Alice, maybe the game coordinator here, doesn't want to wait until the end of the game, so she asks you to determine the winner of the game. Okay, you need to predict the winner, or you need to determine the winner, like who will be the winner of this game. And that's good. It says, remember that Tweedledee and Tweedledum are legendary grandmasters in combinatorial games, so they always play optimally. Okay, that's something you should consider, that they are good players and they would play their best games. All right, let's see if we can try to, or if you can analyze the questions in much easier way. So the question is basically there are two players, okay, D and Dum. So two players, and they're playing on a game of n heaps, and the heap has the ith heap has a of I stones, so it has some number of stones in it. So we can also characterize our players D and Dum as an even player or an odd players. The even player pick up the even number of stones, and similarly the odd player can pick up the odd number of stones. Okay, so the player who is not able to move a stone loses. All right, so the player who cannot remove a stone or move a stone loses the game. So you need to predict, or you need to tell who will win the game depending on who moves first. All right, so you need to tell who will win the game depending on who takes the first turn. Okay, you can just you need to determine who will be the winner of the game. Moving on, let's see what the input and output statements are and how it goes. So the input says the first line input would contain, okay, let's fix the screen like here. So there in an example, there's the input statement and there's the output statement. Let's understand this clearly. So the first line of the inputs contains an integer t denoting the number of test cases. Okay, there is a integer t denoting the number of test cases, t. Okay, this is the integer, the first line. The next one, the first line of each test cases contains an integer n, the number of heaps. Okay, this is the first two in the second line is number of heaps, and a string p, the player that starts the game. Okay, so this string that you see here is the name of the player who is starting the game. All right. Next, it says the string p is equal to d if Tweedle-Dee goes first, or dum if Tweedle-Dum goes first. Okay, so the second line here says that each case contains in space separated integer a of I and the number of stones of the ith heap. Okay, so second line gives you the number of stones that are in each of the heaps. Okay, let's look at the output case. For each test case, output a single line containing either D if Tweedle-Dee wins the game, or Dum otherwise. Okay, so there you can see if we just analyze this game, the test case is 1, so they're in the first input they are giving you one test case, and after that they give you the number of heaps to be 2, and if the number of heap is 2, then you will have this 2 n specified integers, and these are the heaps. So if number of heaps is 2, that's gives you the heap values, what the ith value a of I in each I positions in the heap. And in this is the name of the player that you have. Okay, so if D, because D was one positive player, look, remember D was taking even number of stones and Dum was taking odd number of stones. All right, so D was here, look, 2 was number of heaps. So if D went, so D first choose one of the heap, say D choose this one of the heap, or maybe the first one of the heap. So if D choose this, so D takes even number of test case, like even number of stones. So D can take a minimum of 2 stones. All right. So after that, D takes 2 stones. So Dum will come. The Dum will take 2 stones from like Dum will take odd number of stones. So Dum will take the 1 stone from this. Next D will come, and D cannot pick up any stone. Right? D cannot pick up any stone. So if D can, since this heap will have only 1 stone left, this heap has 0 stone. The first heap has 0 stone left. Second heap has only 1 stone left. So D cannot pick up a stone when the second time D comes, right? So what's the output? Output says Dum. Got it? So Dum is the winner since D cannot pick up any stone in his second turn. So what does it says? The player that can't remove a stone loses, right? The player that can't remove a stone loses the game. Okay, let's understand a bit more details, a bit explain, like try to explain what can be the cutoff, like what can be the test cases that can happen here, right? So let's move back to our whiteboard and see how we can explain this. So here we are in our whiteboard, and let's see how we can explain this. Consider a minimum case, like the smallest example, take a smallest example where we take the n to be 1. What does taking n to be 1 mean? N is basically the number of heaps that we have. If we have only one heap, okay, just consider a test case where the number of heap we have is 1. So there's only one heap, and someone is like one player is going, okay. So now we have one heap. So what can be the cases within that one heap? The heap or the pile can contain odd number of coins, or the pile can contain even number of coins, right? So pile has either odd number of coins, or the pile has even number of coins. That's the possible. So either the pile, the one heap that we have in the smallest case can contain odd or even number of coins. Moving on, look in details, like if odd number of players like plays first, okay. So let's just take this condition, okay. Let's go ahead with this condition first, and let's see how what will happen if the number of piles or number of heaps is 1, and the number of coins or the number of stones we have in the heap is odd, okay. So number of stones in the heap is odd. So let's take an example. Suppose say there's a 5 stones, okay. What would happen if there are 5 stones and there's only one heap? Now, if the first Dum goes first, so Dum was our odd player, right? Dum was our odd player, and Dum goes first. So we are in this condition where number of coins is odd, and Dum goes first. So if Dum goes first, then look, he can pick either 5 of it, like he can, if Dum goes first, then he can pick either 5 of it, or he can pick 3 of it, or he can pick either one of the coins, right? So this is what Dum can do if Dum goes first. Suppose Dum picks any one of this, like if Dum picks 5, what can D do? look, Dum can pick all these things. If I just go back to the question once, look here, there was a statement they gave you here. So in the last statement, they say, remember that Tweedle-Dee and Tweedle-Dum are legendary grandmasters of combinatorial games. So they always play optimally. Okay, that was the important statement here. So they always play optimally. So if they're playing optimally, look how this game goes. So if Dum is playing optimally, so there's no case that Dum will take 3 or 1 stones out of it. Dum will always and always pick 5 stones. That's an confirmed case. Alright. So Dum will always and always take 5 stones. So if Dum is playing optimally and he picks 5 stones, or maybe the odd number of stones that are there, we say that there is an odd number of coins, odd number of stones. So Dum will pick the whole odd number of stones. So if Dum picks all the odd number of stones, then what's left with him? Here, then we have only one pile, and that had odd number of stones. Dum went first, and he picked all the stones from there. So does D win the game? No, D cannot win the game in this case. So in this case, if this is our case, D can never win the game. So that means the even player, the player who is playing on an even number of stones, can never win this game. Look, if D goes first, all right. If there is a case when odd number of coin was there and Dum went first, so Dum will always win. If D goes first, so out of 5, what can D took? Out of 5, D can take say 4, or D can take 2, right? So that's what D can take. Remember? So if D plays optimally, so he will definitely take 4 in this case. So he will definitely take 4. If D takes 4, then also in the second case, Dum will go and Dum can pick up 1, right? So there's no chance of even player winning when the pile contains odd number of coins. If the pile contains odd number of coins, then there's no chance that the even player will win. Okay, even player cannot win if the pile contains odd number of coins. Next, look at the second case. What if our pile contains even number of coins? What if our pile contains even number of coins? So if a pile contains even number of coins, then again we can say we have 6 coins here. So as an example, let's say the pile has 6 coins, or the 6 stones we have. So what can be the case? So if the even player plays first, he will win. How? If the even player plays, if D comes first, so D will place optimally, and he will take all the 6 stones there they have there. So D will pick all the 6 stones, and D will win. So so even player should be the first one to win, right? Next thing, if the odd player plays first, look here. If the odd player plays first, what will happen? If odd player plays first, so odd player have options like he can pick 5, he can pick 3, and he can pick 1. And again, it says they will play optimally. So if the odd players goes first, he will definitely pick 5 number of coins. If 5 number of coins is picked, there remains only 1 coin in the heap. If this even player comes in the second place, he cannot pick 1 coin. If he cannot pick 1 coin, then what remains? If he cannot pick 1 coin, then obviously the odd player wins, right? If he cannot pick 1 coin, like here, minimum coin that he needs to pick is 2, because he is an even player. So he needs to pick 2 coins as a minimum value. So Dum wins. So what's the case that we find here? If the pile contains even number of coins and even player goes first, then it's the only condition that even player will win. Else, at every other condition, our odd player will win. That was the case we found here. So if the pile containing odd number of coins, then the odd player will always win, regardless whether it takes first turn or second turn. Alright. And if the pile contains even number of coins, then if the even player takes first turn, he will win. Else he cannot win. Right. So only condition when even player to win is that the number of coins or number of stones in the pile is even and the even player goes first. Else it's impossible for the even player to win. Now we can find a solution, or we can write a solution to this questions, right? We can definitely write a solution to this question. I hope this expression becomes understandable to you. Let's go back to our CodeChef editor and find out whether we can solve how we can implement this in like I will use Python, and I will show how we can implement this thing in Python. Here we are at the CodeChef again. So let's click on submit and let's type our question. Guys, there's another option. If you know of this, you can upload your source code. Like you can write your .py file in your local machine and upload your file here. But I prefer writing in this editor, so I will go ahead with that so that I can show you how I am doing it. So I will use Python 3, and let's write our write the solution to this problem. Okay, so the solution to this problem is, remember the first statement was number of test cases. So T was our number of test cases. So we'll say int, and we'll say int, we'll just take input. We'll just say take input within T, and we got our T. All right. In the next step, we can do like we need to find for each test case, we need to find who will win. So we can do something like for say T in range T. Okay, if you can't understand this implementation, so when we're doing range T, so this T is basically representing the T we got as input, and this T we are using here, this is the reuse of the variable we took, and we are reusing the variable how? So this T will take a value from 0 till this range, the value given by this range -1. So the value that that's how the range function works. So it gives a value -1. So this was our for statement, and let's move ahead. The first statement we are getting as input was number of heaps, right? So number of heap was n for us, and what else? We are getting a name of the player, right? So name of the player, so let's take it as P, and let's read our input from there. So if you're reading the input, so n was number of heap and P was number of like the player going first. So let's take this input, and you will take this input like I for I in range. Which range we will go for? No, not range basically, sorry. We'll take I, and we'll take I in range. I will take it from the input. So input, and we'll split our input. We will, sorry for the mistake. Yeah, we'll split our input depending on the space it have, right? So we remember that the first line contains an number of heaps and the player going first. So that's how we just took our input and split our inputs in the two cases. Now in the next step, we have our input for the number of heaps, like the values for the heap, right? So what will we do? We'll again say we just take a array, say game, and we'll just assign this game. We'll make it as an array, and in this array we'll again take all those values, or all the value of this heap. Let's say we'll take I, and we'll say for I in, again the similar thing, we'll take it from the input, and we'll simply split our input with that space given in between. Okay, there's the thing goes here. No, I put an extra bracket. Yeah, there's the thing goes here. Anything else we need? Yeah, we need to make sure that this I is an integer value, because otherwise it would take as a string value and we may face problem. So that's the case we have. After that, say we'll just check which condition. We'll check if the player going is even or not. Second thing, we'll check if the player no, the first thing we'll check is if the number of piles is even or not, like 1 or not. If the number of piles is 1, then the player going then we'll check the number of stones in that pile, right? If that's even and the number of pile is 1, then we'll check if the player going is even or not. If the player going is even, then only the player even can win, right? So we'll go like if we'll check the length of game is 1. We just check if length of game is 1, that means there is only one pile. And we'll say next thing, we'll check if game of 0 game of 0 mod 2, that is it's even or not, mod 2 double equals 0. So if game of 0 mod 2 means the value at the 0th position of the game array or the game list is even, and that means we are left to with the check that if the player is, what was the name of the player we have for event case? So it was D, as far as I remember, D, and that's the thing we need to check. That was all we needed. After that, we'll print, we'll print D will win. That is, this is the only case when D can win. Else in all other cases, we'll print that Dum will win. All right, so this is the exact condition that we are asked to solve. Okay, we solved it out. Let's submit this. This is running. Just wait a minute and let's see if we just made any mistakes or not. Yeah, you can see that it's a correct answer. Yes, you did it. You did it. Finally you made a good submission to the CodeChef. Thank you guys for watching this video. I hope I can make you understand how this function works, like how we can solve this problem. And thank you everyone for watching this. If you like the video, make sure to press the like button. Also subscribe to my channel for this kind of regular videos. I am also doing an data structure and algorithms video series. Make sure you watch that too. Thank you everyone.